So today we're going to learn about bases for subspaces. So we've learned about subspaces last lesson, and we're going to use subspace H to illustrate the definition of the basis. So a basis of subspace H contains linearly independent vectors that have a span of H. If you're not sure what any of these words mean, please watch my previous videos, they're really helpful. Okay, so let's just move on to a few example problems to more clearly define what a basis is, because right now we only have one sentence of definition and we're kind of miffed. Okay, so let's say I have a subspace H, and so I have a subspace H, and I want to know that whether or not, so let's say H was, let's say H is R3. So R3 is a subspace because it meets the three rules, the three conditions that we need for a subspace and basically they are that H contains a zero vector, and it's addition. So any two vectors in H that add together form a new vector that is in H, and any vector in H multiplied by a scalar forms a new vector which is also in H. So H is equal to R3, basically the 3D coordinate system, the one with X, Y, Z. So I want to figure out whether or not, firstly, let's see, whether or not 3, 2, 1, so this is a vector, and another vector 4, 5, 3, and another vector -1, 2, and -5. I want to see if these vectors can be a basis of R3 or H. So are these a basis of R3? Well, the first thing is that they have to be linearly independent. So if I draw the three vectors, I want to make sure that neither can be a linear combination of the other two. And if we actually draw the vectors, we figure out that yes, they are linearly independent, and so do they have a span of R3? Because if they do, then the answer here is going to be yes, they are a basis for subspace H. So do they have a span of R3? Well, yes, they do, because if the three vectors are linearly independent, well, then they do have a span of R3. So the first question here is going to be true. So let's look at another example. So we are still trying to figure out a basis for R3. So let's say this time we have vector 1, 0, 1, 0, 0, 1, and 1, 0, 0. So is this a basis for R3? Well, no. Why is that? Because we know that, so firstly they have to be linearly independent, and this is not linearly independent because we can have, so we know that 1 times vector 0, 0, 1 plus 1 times 1, 1, 0, 0 is equal to 1, 0, 1. So one vector here, 1, 0, 1, can be provided and given by the linear combination of the other two vectors. This means that the resulting span is going to be a 2D plane, not a 3D coordinate system. So this doesn't even span R3, so there's no way for this to be a basis for R3. So let's look at another example. Say 2, 3, 5. And also 4, 2, -3. So these are just some random numbers. And we also have, let's see. We also have 10. So we have 10, 7, and -1. So we're tempted to answer yes, because, well, it just looks like yes, right? So bye guys, enjoy the video. So, however, that's not the case, because essentially we have 1 times 2, 3, 5. If we add that to 2 times 4, 2, -3, this will give us the resulting vector 10, 7, -1. So therefore, the 3 vectors are not linearly independent. So this is not a basis for subspace, for the subspace R3. So thanks for watching. Bye.